All right, welcome to The Explainer. Today, we are getting our hands dirty. We're going to build an AI agent's brain basically from scratch by really digging into the control flow of LangGraph.
So, here's the game plan. We're going to start with the big why. Why do AIs even need to loop? Then we'll build up, block by block, until we have a fully functional agent that can think for itself.
Okay, let's jump right in. First up, what's the core problem that LangGraph was even designed to fix?
You know, a basic Q&A model is great, but it's kind of like a transaction. You ask, it answers, and that's it. It's a one-way street. But for a real agent, we need more. We need it to think in a cycle, right? To try something, check the results, and then think again based on what it learned. And that, right there, is why we need a loop.
So, to get that loop going, we really just need two key things. First, some kind of memory, a way to keep track of everything. And second, a way to actually do stuff based on what's in that memory.
All right, piece number one is the state graph. The best way to think about this, it's the agent's memory. It's its central whiteboard. Everything gets written down here. The original question from the user, what a tool just found, even the agent's own private thoughts. It all goes on the whiteboard.
And the second piece, that's the node. If the state graph is the whiteboard, the nodes are the ones doing the writing. They're the doers. They're the functions that perform actions or, well, think. A node walks up to the whiteboard, reads what's there, goes off and does its job, and then comes back to write the result right back on that same whiteboard.
And this is so important. Everything, and I mean everything, revolves around this shared state. It's the single source of truth. Having it all in one place means every single part of the agent is always looking at the same information. No confusion, no mixed signals. It just makes the whole thinking process super reliable.
Okay, so we have our whiteboard and our doers. Now, how do we connect them? Before we can get fancy and give our agent a brain to make choices, we first have to build the skeleton, the basic, rigid structure of its workflow. And LangGraph gives us some really simple, clear tools for this. You get a set entry point. This is where you start, no questions asked. You get add edge for creating those fixed paths between steps. And you get a set finish point to say, okay, we're done here. Start, connect, end. Super straightforward.
Now, don't sleep on this add edge function. It sounds simple, but its power is huge. It basically creates a one-way, guaranteed path from one node to another. It says, after you do A, you will do B. And this isn't just for simple sequences. This is the magic key to creating loops. It's how we force the agent to go back to an earlier step and, you guessed it, think again.
Okay, a rigid skeleton is good. It gives us structure. But, a pile of bones isn't very smart. A real agent has to make choices. So this is the part where we give our graph a brain.
And here it is. This is really the star of the show. Add conditional edges. This one function is what transforms our simple flowchart into an intelligent agent. It gives the graph the power to look at its own memory, that whiteboard, the state, and make a decision about where to go next.
So how does it work? It's basically a three-part recipe. First, you say when the decision happens, right after this specific node. Second, you give it the brain, the logic. That's a routing function that looks at the state and makes a call. And third, you tell it what to do based on that call. You map the outcomes, like if it says A, go here. If it says B, go there. And this right here is a brilliant design choice. That routing function, its job is to look but not to touch. It inspects the state, it reads the whiteboard to figure out where to go, but it is strictly forbidden from changing anything on it. This separation of powers is absolutely critical. Think of it this way. Nodes do things. They change the state. Edges decide things. They just control the flow. Keeping these two jobs completely separate makes everything so much cleaner and honestly way easier to debug when something goes wrong.
Okay, theory's done. Let's put all these pieces together into something real. We're going to build the classic React agent, a perfect example of a powerful loop that combines reasoning and action. So the React pattern, it's pretty much a foundation for a lot of modern agents. It stands for reason, act. The agent reasons about a problem, decides on an action, usually calling a tool, and then observes the result to start the reasoning process all over again. And what's cool is that LangGraph makes building this loop feel, well, just incredibly elegant.
You can literally map out the entire thinking process in just 4 steps.
Check it out. First, we start at the assistant node, where the reasoning happens. Then comes the big decision point, our conditional edge, which asks, do I need a tool, or am I done? If the answer is tool time, we head over to the tools node. And after the tool runs, a simple fixed add edge yanks the flow right back to the beginning, forcing the assistant to look at the new info and reason all over again.
Yeah, this table just lays it all out perfectly. You can see exactly how those LangGraph functions map to the agent's thought process. Set entry point gets the ball rolling. Add conditional edges is the brain making the choices. And good old add edge is the workhorse that just closes that loop every single time. So you might be wondering, okay, this is cool, but why bother? Why go through all this trouble to define the logic as a graph? Couldn't I just write a big function with a bunch of if statements?
Well, the payoff is massive. Because you're declaring the entire workflow up front, you can actually see a map of your agent's mind. This makes debugging 1,000 times easier, but it also unlocks some seriously powerful stuff, like running different thoughts in parallel, building in really robust error handling, or even getting multiple agents to work together as a team.
And look, this isn't just some abstract theoretical advantage. This explicit declarative structure is the reason tools like LangGraph Studio can even exist. You can literally watch your agent think in real time. You can pause it, inspect the whiteboard at any step. It's basically like having a time-traveling debugger for your agent's brain. It's a game changer.
And really, that's what I want you to take away from this. These ideas, the state, the nodes, the edges, they aren't just lines of code or abstract concepts. They are the Lego bricks for building the next generation of intelligent systems. Systems that can actually reason, act, and learn all by themselves. So now that you know how to build an agent that thinks in loops, what problems are you going to solve?